From ContainerDays Hamburg, this video is proudly presented by Dux IT.
For those of you that don't know me, I'm Marcus Noble. I am a very new platform engineer at Monzo. This is technically my third week there. I run a monthly cloud-native related newsletter called cloudnative.now, where I can do like a roundup of everything that's happened in the past month in the cloud-native ecosystem and all the tooling and stuff. And I'm a CNCF ambassador. As of now, I have roughly about 7 years worth of experience running Kubernetes in production environments. Over that time, I've had a bunch of different roles. So I started off as an app developer, like a full stack Node.js developer, deploying stuff onto Kubernetes clusters just for our single team. So we were managing like a dev staging and production cluster within our team. I then moved into more of an R&D sort of role, building out tooling and best practices for a multinational organization. Moved then more into platform engineering, release engineering, and that kind of thing around Kubernetes and doing it for customers and for internal teams and things like that. So I've touched quite a little bit of different areas of Kubernetes over my time. So hopefully you will trust what I'm going to say to you is kind of good. And I'm here today to talk about dynamic admission control. Now, historically with Kubernetes, what we mean when we talk about this is validating admission webhooks and mutating admission webhooks. The use of these kind of falls into 4 categories is the way that I see it. So you have like defaulting logic. So these are things like being able to inject image pull secrets into all pods that are created within a particular namespace. There's policy enforcement. So your security team may want to make sure that you're not using things like the latest tag because that's a mutable thing that could, break or introduce some weird CVEs that you don't want to have. There's best practices, so things like ensuring that all your production workloads have a pod disruption budget, specify the right resources, things like that. And then my favorite area is what I call problem mitigation. So who here remembers the log4shell exploit from like a few years back? Yeah, it was pretty big thing. We were actually able to effectively turn that off, fix that problem in all of our clusters by using a mutating webhook that set a very specific environment variable on every single container that got launched within that cluster. And what this meant is the code path that was exploitable was actually just then turned off. Like it didn't even matter if that container used log4j or not. We just applied it to everything, and then instantly every new pod that got launched in our cluster was safe from that exploit. And it was a really, really good use case of this kind of capability within Kubernetes. But while these webhooks in Kubernetes are powerful, they do come with a certain amount of risk. If they're not configured correctly, or if your service that's powering them has some sort of trouble, they can take a small issue in your cluster and turn it into a catastrophic cluster failure that takes your API server down. Now, I'm not going to talk about this today. I've actually given a talk about that topic before. So if you are interested in the ways that your clusters can go wrong from misconfigured webhooks, I have a talk from KCD UK a couple of years ago now where I go into detail about that. But what I'm going to talk to you today is, wouldn't it be great if there was a safer alternative to these webhooks? And it turns out, yes, now there is. So I want to introduce you to ValidatingAdmissionPolicies, not webhooks. These were introduced in Kubernetes 1.26 as an alpha, became beta in 1.28, and are now generally available for everybody to use from version 1.30 of Kubernetes. These are, this is the kind of description of it, a declarative in-process alternative to validating admission webhooks. Now, what we mean by that is declarative in that you define them with Kubernetes manifests, just like you would a pod or a deployment or whatever. In process as in inside the API server itself. So there's no external services that you have to rely on. As long as your API server is running, these can also run. If your API server is not running, you have other problems to deal with. They use this thing called Common Expression Language, or CEL, which is what I'll be referring to it as throughout this talk, and we'll go into a little bit more on that shortly. That's the policy language that it uses, so that's how you write your expressions. You write it in this CEL language. And it consists of 2 main resources that are now available within Kubernetes. So a validating admission policy, which describes the logic you want to apply, and then a validating admission policy binding, which tells your cluster what things to apply that policy to within your cluster. And we'll look at these shortly. So, brief introduction to CEL. If you were here on Tuesday, Victor actually gave a really good talk that introduced CEL and gave some really good examples. If you weren't able to see that talk, I recommend looking for the recording when it comes out, because he did a much better job than I'm going to do on this single slide. But it's a very similar, like C-like language. So the example here, you can see self.min replicas is less than or equal to self.replicas, and self.replicas is less than or equal to max replicas. And it's designed to be embedded in other languages. So you don't normally run a CEL expression on its own. It's like within another binary usually. You use it as like a plug-in functionality or something like that. And it's kind of a focus on what I call one-liners. It doesn't have to be one line, but generally like small amounts of code. It does have some small built-in functions, so things like split and has and stuff like that, which we'll see shortly. And you can extend it with your own custom functions. So in Kubernetes, they have extended it with some like Kubernetes-specific functionalities that you can also use within CEL. And you may have already come across this in other tooling in the cloud-native landscape. So Caverno, Tecton, KubeWarden, all of these use CEL in some different areas of their tooling. And if you want to learn more, there's some resources on the side, which I highly recommend. And I'll share links to all these at the end. So let's have a look at an example. For this example, we are going to go for the quite common one of blocking the use of the latest tag within our cluster. We don't want anybody to use images with the latest tag. We want them to use versioned ones. So first things first, we're going to have to give this a name. So like any resource, we give it a name. This is what will then get referenced by our policy binding later on. We want to use the failure policy here. So the options for this are either fail or ignore. Now, this is the failure policy if the CEL expression is malformed, not if it's not met. So this is if you have like a typo in your expression or something like that. Do you want it to fail your, do you want it to throw an error, or do you just want it to like kind of carry on? And then you've got some resource rules. So this tells you what resource types within Kubernetes this policy can apply against. And these types will then be useful in a minute. You can also then define the operations that it's going to apply against. So these are your API call operations. So create, update, delete, connect, and then star if you just want to apply to everything. One thing you will note here is we are actually targeting deployments, daemon sets, and stateful sets. I'll explain that in just a second as to why it's those three. And then validation is where we actually then start writing our logic that we want to enforce here. It's worth noting that this is an array, so you can have multiple expressions in here, multiple validations that you want, and all of these are ANDed together. So they all have to pass for it to be for your API call to be accepted. The first thing that we got in this validation is a message. Now, this is optional, but I highly recommend that you provide a message, because if you don't, the error message that the user gets is your expression, the whole thing printed out to the user, failed. And that's not helpful at all for a user. You want to give them a bit of hint as to what to go on. And then we've got our actual expression. So this is where CEL comes into play. Now, one thing to be aware of here, which I still keep getting caught out by, this is the expression that matches what is allowed, not what you want to block. So this here is what you want to allow to happen. This is what a good API call looks like. And first off, we start with this object. So object here is a special thing in this policy that refers to the incoming API resource that you're matching against. Now, I said here we had deployments, daemon sets, and stateful sets. The reason that I'm using those three is, for our purposes, their API spec matches what we want to work against. So they all have spec.containers.image, right? So they have the same pattern. If you had different resources that have a very different schema, you would probably want different policies against to use. Otherwise, your expression gets very hard to write, because you then have to do, does it have this property? Yes, no, blah, blah, blah. So I recommend only using ones that have the same schema and then have multiple otherwise. So then we see here we've got our spec.template.spec.containers, which is what I said it matches on them all. And then we've got one of these built-in functions called all, which allows us to do an operation on an array. So we're doing this on the array of containers. And we get a variable for each of the ones, so it's container here. And then we want to check that, oh, sorry, I've gone too far. Want to check that the container.image and then another built-in function ends with latest. sorry, it doesn't end with latest. We've got an exclamation mark at the beginning. And the fact that we're checking that it also does contain the colon, because if it doesn't, then it's implicitly latest because we haven't provided a tag. And then also we want to check whether our init containers have the same problem. So this is where we can then use the has built-in function to see, first off, does my resource have init containers defined or not? And if it does, then we can start doing operation on them. If we didn't have this check first, this would actually error out if we didn't have any init containers on our resource that we're trying. So always make sure that if it's an optional field, you are checking that it exists first before you're trying to do anything against it. Cool, and then we've got our bindings. Like I said, you create the policy first, and then you have to tell your cluster what to actually apply it against. And in here, we have the policy name that we had from the previous one. Again, it's just the metadata.name. And then we have some validation actions. So the available options here are deny, warn, or audit. This is actually an array, specifically because you're able to supply warn and audit together, but that is the only combination of more than one you're allowed. It's only because you can then give a warning to the user, but also have an entry in your audit log. By default, most of the time you're going to have this as deny because you want to actually apply you want to enforce your policy. But in the early days when you're introducing this new policy, you may start off with warn to let users know that this policy is coming in and you want to give them time to fix that stuff up. And then finally, we have match resources. So this is just kind of a standard Kubernetes struct that kind of match against what we want to do. In this example, it will match against anything. But we could say, actually, we want to match against all namespaces that have the label environment prod. Now, obviously, in a real world, you are not mixing prod and non-prod in the same cluster. You have them in separate clusters. But for our contrived example, let's assume we have a specific prod environment, and we only want the policy applied to things in there. And that's how you do it. And this can be whatever sort of selectors that you need. And here's an example. So I'm trying to apply an Nginx using Nginx latest on the end, and we get this error back when we try and do an apply. And as you can see here, this is our nice, friendly error message that I was very adamant about earlier. Otherwise, we would have seen that big, long expression in here, and that's not fun for the users that don't know what's going on. So that's the kind of happy path, the simple, basic example. Let's have a look at some of the more advanced features that are available with these validating admission policies. You can have more context values. So we've already seen object, which is the incoming resource object from Kubernetes. If the operation that's being performed is like a patch or an update or a delete, something like that, you'll also have old object, so you can compare the previous state to the new state. You also have namespace object, which gives you a reference to the namespace that resource belongs to if it's a namespaced resource. And then you also have the request object, which gives you some information about the thing making the actual API request. So in the example here, I just implicitly trust Kubelet. I think Kubelet knows what it's doing. I'm just going to let it do anything. So in my example, because I know Kubelet is part of the system nodes group, I'm going to make sure that this only applies when system.nodes is not in the request.userinfo.groups. So if the API request being made has system nodes in their groups, fine. We trust the kubelet, do what you want. You can have parameters. So parameters allow you to then use a single policy in multiple different ways. So you may have different values that you want to use potentially in different namespaces, but don't want to have to duplicate your policy each time. The way you would do this is you'd have a single policy, as you can see on the far left. Here we're doing object.spec.replicas is less than or equal to params.data.max replicas. So here we're making sure that we have the number of replicas in our pod. And we're using a config map as our param kind. So we use a config map as a source of our variables. In the middle, we've then got our policy binding, which takes this policy that we've defined and binds it to a specific parameter reference. So in our example, it's a config map called my parameters in the default namespace, which we've got on here, and you can see max replicas is set to 3. So this expression will make sure that at most we are having 3 replicas. Now, in a different namespace, we may want to have a different policy binding that is 10 max replicas. So we can use the same policy, different policy binding, different config map, and then have that as a configurable thing. We've also got variables, not to be confused with parameters. So variables you define in your policy itself, and these are effectively reusable bits of CEL. So as I said, CEL's generally aimed at like one-liners. Once it gets quite long, it's hard to work with. So you've got this concept of having variables, so you can like shrink some of the CEL down and reuse it in your actual expression. So in this example, I am checking for the team the team value to exist on object.spec.metadata.labels. And we've got a tertiary operator here. If it does exist, team label variable becomes the value of that label. Otherwise, we default it to no team. And that means then that in our expression, we can compare that variable that we've set against whatever we want. So here I'm making sure that the label set on the object is releng, for example. And then we've got audit annotations. So I said earlier that one of the actions that you can have is to have this audit show up in your audit logs. You can also provide additional data in those audit logs in the way of annotations. So on your policy, you will create this audit annotations array, and it's just a key value kind of thing here. So you provide a key name, and then you can have value expression, which allows you to actually write a CEL expression as your value. So this can be a dynamic thing. So here we're saying deployment spectre replicas set to, and then we're actually pulling out the actual replicas. So it would end up being in your audit log. It gets prefixed with the name of the policy, then your key that you've defined, and then deployment spectre replicas set to 128, which is way higher than the 3 we set earlier. And then finally, we also have message expressions. So I said how important the message was to have. If you want to have a more dynamic one to make it even better for your users, you can use message expression instead, where you can then use CEL expressions in that string. This is super useful if you are using it with parameters, because you can say object.spec.replicas must be no greater than, and then actually pull out the value that we're comparing against. So that is then dynamically based on the binding and the config map that we've set earlier. Cool. So that's validating logic covered. But what about mutating? So I said earlier on, like some of the really good examples that we had were like being able to mutate pods that they were creating and stuff. So, well, let me introduce you to mutating admission policies. Now, these were introduced in alpha as in 132, and as of 134, they are only beta. So they are not enabled by default yet. You can enable them in your clusters today, but you have to actually turn them on through a flag. They follow the basic idea of validating admission policies, introduces 2 new resources, mutating admission policy and mutating admission policy binding. And they currently support 2 patch strategies, apply configuration and a JSON patch, so depending on how you actually want to mutate your thing. And as I said, they're not yet enabled by default. So if you do want to enable them, you need to turn on the mutating admission policy feature gate and enable the admission registration API. If you're using 133 or earlier version, this was actually a V1 Alpha 1, so you may get caught out by that. If you want to try this out in kind on your local cluster, you can use this configuration here, and then just kind create cluster and point it to that, and it'll bring you up a new cluster with this enabled, so you can try it out and play. So let's have a little look. In this example, I'm going to inject some environment variables into pods, which are going to be used for a HTTP proxy. So I don't want to have to share that information with all of my app developer teams, but I want to make sure that my cluster is all the traffic's going out via a HTTP proxy. Let's just make sure that any time a pod's created, it's automatically set. So similar sort of thing as validating admission policies. We have a failure policy, so what happens if we've got a typo and we've got match constraints. So here we only care about when pods are created. That's all this cares about. We've got a reinvocation policy. So this is very similar to the mutating webhooks. This is what happens if you have multiple things mutating say if you had multiple mutating admission policies mutating the same resource, do you want it to try and remutate again? So you want to make sure that you always apply against the latest. Now, it's worth noting that this will only retry 1 additional time, so you don't get stuck in like a loop of 2 policies fighting against each other. Same sort of logic as with the webhook, so if you're familiar with those, it's the same sort of thing. And then we replace our validation with mutations. So we have the patch type, as I said earlier. We've got apply configuration or JSON patch. In this example, we're going to go with apply configuration. And then you define it here as an object and an expression. And this is where we get an introduction to named types within CEL. Here it's object with a capital O, not a little o. This is a class. This class will be whatever the resource is that that the API call is being made against. So in our example, it's pods. So object here is the pod spec. And we're saying that on spec, where we go, spec containers, and then we're using the map function on the containers array. So there's another built-in function so that we can mutate all of those containers within that containers array and say we're going to inject a new environment variable into the env array. Oh, sorry, I went too far. Where we set HTTP proxy, and in this example, it's just proxy.proxy.service, whatever. Now, what's worth noting here is if your resource spec already has this environment variable set, this will overwrite it. So this will always win, basically. And just note that, like in this example, we're ignoring init containers and ephemeral containers, but you'll probably want this longer to actually include those as well. But space. And then the policy binding is pretty much the same sort of thing that we've seen previously. Nothing surprising here. I'm not going to go into too much detail because, policy name, match resources, and also whether we want to define a parameter reference or not against it. But let's have a look at the advanced features. Mostly the same as with the validation one. So you've got those context variables, you've got parameters, you've got variables. There's nothing surprising there. What you don't have is audit annotations and message expressions, because that doesn't make sense in the mutating workflow, because that's not returning back to the user. That's not a validating action. So nothing these are not used for blocking actions and API calls. Cool. All good so far. So as of now, mutating admission policies are coming very soon. Hopefully, the next release of Kubernetes will have them as GA, but I do recommend you turn on the flag, try them out now, see if they can suit your use case. But let's have a look at what might be the future beyond that. Now, all of this is speculative and wishful thinking on my part, but there are indications that these kind of things are probably coming. One of the things that we might see is generative policies. So this is the ability to create new resources based on some API requests. So this is possible today with webhooks because it just runs some code somewhere. A good example of this is when creating a new namespace within your cluster, you may want to pre-populate that namespace with a image pull secret automatically so you can pull from your private internal registry. The ability to do resource lookups within your cluster is more than likely coming. This is a very common use case where you want to compare against other things within your cluster when you're doing your validating or mutating logic. We kind of have this with parameters, but it's quite limited in how you can work with that. So being able to, say, look up values from a secret or whatever would be quite useful here. Policy exceptions. So this is something that a lot of enterprises very much need and use with a lot of the third-party policy enforcement tools within Kubernetes, is the ability to have like a strict policy that applies everywhere, except for my little special application that I trust. Like that, I need some way of allowing that to be naughty, effectively. Policy reports. So this is a way of easily seeing the validation failures across your cluster. Now, you do get this in the audit log, but I don't know about you, I'm not particularly keen on trawling through the audit log. I like a nice, pretty UI when I can. There is a project at the moment called Open Reports that is being run to try and create a common, open way of reporting on policy validation and stuff. There's not yet any work that I've seen based on validating admission policies in this, but a lot of the third-party tools like Caverno and KubeWarden are working towards this open report initiative. So I think that's probably the way that Kubernetes itself will go if it goes that way. And then finally, more abstraction. So we're already seeing this today with Caverno. So Caverno is a very good policy tool for your cluster that does a lot of this stuff already, but it relies on things running in pods and things like that. They have introduced, as of 1.15, mutating policies. They've already had validating policies. These effectively map to validating admission policies and mutating admission policies on the cluster, but then add some extra niceties as well that you may want to take advantage of in Kyverno. The way they do this is if you use any of the non-standard stuff, it will run in Kyverno, whereas if you use the stuff that's all available by validating admission policy, for example, it will just create a validating admission policy in your cluster for it, so you've got all the nice safety capabilities there of it running in the API server. It's very, very nice the way they've done this. And I imagine we're going to see more of this sort of thing. So, to wrap up, if you can, I recommend it's now time to start replacing your mutating admission webhooks with these policies where possible. The caveats here being, if you need to access any third-party resources within your cluster and that kind of thing. If you are on 130 or later, and I kind of hope most of you are at least, you can use validating admission policies today. They are generally available. They're enabled by default, and you can go ahead. They are really good. As I said, 132 was when mutating admission policies went alpha, and then 134 is when they went beta. Both currently disabled by default. You have to turn them on with the flags. And then hopefully in the future, we're going to see more of these abstractions, generative policies, and things like that. And if you want some more examples of how to use these policies, I have started, it's still a work in progress, but I've started a repo where I've started collecting some of these. There's not much there at the moment, but if you do have any that you want to contribute, I would love to see them. And with that, I'd like to say thank you. You can get the slides there. And if you have any feedback at all, I would also very, very much like to hear it. Thank you very much. It's only a problem during the API call. So it's not like it's an impact, the entire time it's running. What happens is when you make an API call against the API server, so you do like a kube control create or whatever, there's a few stages that it goes through, and one of those stages is applying these policies. It's at that point where that little bit of code will run. And then at the very end of that is where, assuming everything passed, it applies it to etcd. The good thing about CEL is it's like really designed for this super small use case embedded within other things. So it's very lightweight, it's very efficient, and you're not going to notice it, honestly. Unless you are running like thousands of policies against one resource, I would be very surprised if you notice any CPU impact from this.
Thank you. Next question is, how can I test validation policies inside CI before applying them?
Spin up kind, do it that way. It's probably the easiest way of doing it. I'm not sure if I've come across any test frameworks yet for validating admission policies and mutating policies. I know if you're using something like Kyverno, they do have testing tooling for their policies, so you can do it that way, and like you run like a little CLI and that kind of thing. But honestly, if you have the capability to spin up a kind cluster and actually apply these things and do like a thing against kind cluster, that's a nice way of doing it if possible.
Sounds like a good idea. What about observability, simple way of seeing failing policies?
Audit log is the best here. So I believe you also see them on events, if I remember correctly. So if you've got them set to warn, you will see them on the events. But if they are set to deny, they implicitly then also populate into your audit log. So if you are interested in this kind of thing, I highly recommend you are keeping track of your audit log, you are looking at these things. But also this is where I think some work's going to be done on like the reporting side of things. So hopefully like that open reports will then give you a way of like a single pane of glass way of seeing things that have been failing and all that kind of thing. Hopefully it's coming in the future.
Thank you. Any chance to break the Kubernetes API processes with in-process policies?
I mean, there's always a chance. You've worked with computers, right? Realistically, no. CEL is designed for this specific kind of use case to be safe. It's got this concept of cost. So it calculates this kind of thing ahead of time and makes sure that you can't, for example, run an infinite loop. So there's not really I mean, theoretically, there's not really a chance of taking down your API server with this because it has guardrails in the CEL language. I don't know much more than that about it, so please don't ask me any specifics.
Will CEL replace the webhooks completely in the future?
I hope so, but I doubt it. There's a lot of cases where you want to do some like really specific gnarly logic, which you can only really do in code. Like you may want to call out to external services. You may want to do some of this a bit more process intensive, perhaps, whereas CEL is really not the kind of language to be doing this in. Like I said, they're really designed like these one-liners, and if you do need to have like 5 function calls to do your logic, it's going to be horrible to write that in CEL. So I don't think we're going to ever see webhooks go away completely. At least no time soon, for sure.
Thanks. What would make you pick a third-party tool like Kyverno over using validating admission policies?
Depends. I would recommend starting with the inbuilt stuff because it's the most lightweight and it's the least external resources to rely on. It's the less things to go wrong. But if you start to find resistance in writing those policies, you start to come up to like some of the edge cases or some of the limitations that I mentioned, which we'll hopefully see in the future, maybe not. That's when I think you should then look at a third-party thing like Kyverno, Kubernetes, or whatever.
This next one in the log for shell example with maps, I can mutate new creation, update of resources. Is there a way to list or fix vulnerable resources already in the cluster?
Not with VAP and map specifically. I mean, you would do it by doing like kube control commands and then some bash script or something to filter. There's no kind of like, there's no list all things failing this policy that already exists currently. But that is, again, perhaps something that could come into the reporting side of things when we get more of that capability. Sorry, quickly on that, Kyverno, I know, actually has the ability to apply these policies in the background on existing resources. So that might actually be a reason why you would want to choose something like Kyverno rather than these. So it's not just a case of only on create. You could target just creation, but also then backfill it to all your things that have previously been created if you choose to, which you don't have in map.
Thank you. The last one being, thanks for the HTTP proxy example. Sometimes you still need to inject a certificate. Yes. Basically anything that you want to kind of inject in and you don't want to have to then tell all of your app developers, yeah, you need to include this into your manifest for reasons. This is a really good way of doing it just at the cluster level. Save them some time. You then have control over it as cluster admins. You could, or you can mount it as a volume, perhaps. It depends on what how it's going to use the certificate, right? If you're able to point it to a directory on that. Also, do you mean for the actual specific proxy use? Yeah, for the specific proxy, yeah, you may. Sure. Yeah, that was quite a contrived example that I've slimmed down just to fit on because it showed something. Yes, you probably would need more than just that, perhaps depending on your environment.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.